this session I am going to explain the same topic, that is problems based on scheduling. So we already discussed first in first out method, and I'll be discussing shortest job first. So under that we have one more method called as preemptive scheduling. Okay, so I told you what is preemptive. Preemptive is, suppose we have different states, like as I told you, running state, running status. When any process is under execution, that will be in running state. Okay, now we have ready queue. Ready queue is nothing but all the process that is ready for execution will be present or will be in the queue called as ready queue. Now the scheduler is going to select any one process and it is going to send it to running state. Okay, now if any process comes, say for example I have P1 and P2, in between if I get one more process P3, so I have three processes in ready queue. Now when this, suppose say I have P1 is being executed, P1 is being under execution or it is in the running state, so it is removed from the ready state and it is moved to running state. So process 1 is executed by CPU. Now if we remove this process 1 and we send it for waiting state or for any input output, if I send the process P0, P1 or P1 for any of these things, that is either I can send for waiting state or I can send for let us say input output. This is nothing but we'll consider as pre-emitting, okay, or emitting. That is nothing but we are going to take out the process which is currently running. The currently running process was P1. We are going to take out that process from running state and we are going to move it to waiting state. Or if the process wants input output, we will go for input output. If not, we'll send it to waiting state. From the waiting state again it will come back to ready state. So the process of removing any, it is nothing but the procedure of removing any process from running state to waiting state or ready state is nothing but pre-emission. So it is simply to say that if any one process that is currently executing, we are going to take out that process from execution, and that process will be in that particular place. So the CPU will execute other process. So I'll execute P3 here and I'll start executing P1. Okay, so we'll stop the execution of P1 and then we're going to send it to waiting state or we'll send it to ready to run state, but we're going to select P3 for execution. So that is nothing but pre-emission. So previously we have discussed the whatever concept that we have discussed, that was based on non-preemptive scheduling, in the sense once any process starts execution, until the completion of its execution we are not going to remove it from the process or running state. From the running state, if you are not removing any process, then that type of scheduling will consider as non-preemptive. That is, any process under running state will not be removed, which is non-preemptive. Preemptive is if any process that is running can be removed or can be taken out from execution, and instead of that process we are going to execute the other process. So this type of process will consider as preemptive scheduling. So basically you need to understand one thing is, we have discussed two types of scheduling till now, or scheduling problems. One is first in first out, which is by default non-preemptive. Okay, so first in first out is always non-preemptive. There is no, we are not going to discuss regarding preemptive and first in first out. When you come across shortest job first, we have both non-preemptive as well as we have preemptive. Both the methods are present in shortest job first. Previously we have discussed non-preemptive of shortest job first and non-preemptive of first in first out. Now today we are going to discuss shortest job first, preemptive. Okay, so I have taken a problem. So where we'll have process 1, process 2, process 3 and process 4. I have 4 processes where arrival time is given as 0, 1, 2, 3 and burst time is given as 8, 4, 9 and 5. Okay, now if I want to draw the chart or the current chart, so before drawing the chart In this chart, we are going to represent the process, its arrival time and its completion time. Now, first, at 0th millisecond, I have a process called as process 0. So when it was 0th millisecond, we have the first process which is P0. So if you observe, we have P0 was the first process 1 has arrived at 0th millisecond. So at the beginning, we'll start with process 1. So when I start with process 1, it was started at 0th millisecond, and so it has burst time of 8 milliseconds. But once I complete first millisecond, once I complete the first millisecond, what happens is, that is, say if you observe, once I complete the first millisecond, we have process P2 has arrived into the queue, ready queue. In the ready queue, I have also having one more process called as P2. If you observe the burst time, so we have completed 1 millisecond here. If I have completed 1 millisecond, rest, left out is 7 milliseconds. But P2 has, what is the burst time of P2? P2 is having the burst time of 4. Now, this 4 is less than 7. So, we can complete this process P2 faster compared to that of P1. So, the scheduler, what it does is, it is going to stop the execution of P1. It is going to stop the execution of P1 at 1 millisecond. And it is going to select which process? Process 2 will be, P2 will be selected for execution. And if you observe, when process P2 completes 1 millisecond, we'll get one more process called as P3, which is having burst time of 9, which is greater than 4. So we are not going to select that, or we are not going to swap P2 with P3. Similarly, when you observe P4, P4 is arrived at 3 milliseconds. It is having the burst time of 5, which is again say greater than 4 milliseconds. So we are not going to select that also. So that is until the completion of this process P2. So process P2 will be completed at 5 milliseconds. That is, it has started at 1 millisecond, 4 milliseconds of burst time, it will complete by 5th millisecond. So this has been completed. So this particular process P2 has been completed. Okay. Now if you observe, we have 3 processes now. One is P1, P3 and P5. So in P1, it is having burst time of 7 milliseconds. We have already completed 1 millisecond of its execution. We need 8 more milliseconds for, 7 more milliseconds for execution. Again, we have P3 and P4. Now, lowest is what? P4. So now next we are going to select P4 for execution. And once P4 starts, P4 is having 5 milliseconds. So 5 milliseconds, 5, it will become 10. So we'll complete next the P4. P4 will be completed. So once the completion of P4 is done, next we'll see the other process. We have P1 and P3. So P1 is having 7 milliseconds. So next we are going to select P1 again. So once P1 is selected, it is going to have 7 more milliseconds. It is nothing but it will end at 17. Okay. Now at last we'll have P3. So this is 17. And at last remaining is we have only P3. So P3 will start execution and it will end at say 26. Okay. So that will be the end of this chapter. So here you need to keep in mind, when any process is under execution, during its execution, if there is any new process with lesser burst time, so the current execution will be stopped and it is going to select the other process with lesser burst time. So that is how you are going to write the chart for preemptive scheduling. Okay. Now based on this, we can calculate waiting time. So we need to calculate turnaround time. We need to calculate then response time, and we need to calculate average process time or throughput. Okay. So we'll see one by one. First, waiting time for process 1. So if you observe, process 1 has been executed twice. Okay. Now according to this, we should write down your waiting time also. Waiting time was what? It was like submission time minus arrival time. So submission time is nothing but first it was submitted at 0 and it was arrived at 0 itself. Okay, but it has stopped there. It has again started in one more place, right? It has been stopped here and it was been in the sense for 1 millisecond it was executed. After 1 millisecond it has moved back to ready queue. For ready queue we are going to move back that particular process to ready queue again. We have stopped executed only for 1 millisecond, rest 7 milliseconds are pending. When we have started it, we have started at 10 milliseconds. So again, next time the submission time will be what? 10. So 1 milliseconds it was stopped. So it was again second time, and when it was arrived at 1 millisecond. Okay. So in the sense it is just like for when at the beginning it has arrived at 1. After execution of 1 millisecond, next arrival time will be 1. Okay. So at the beginning when it was started its execution, the arrival time was 0. The arrival time of P1 was 0. So at the starting of execution, P1's arrival time was 0. As you can see, P1's arrival time was 0. After execution for 1 milliseconds, next time whenever it starts execution, its arrival time will be 1. Okay. So we have written the same thing here. Okay. So and second time when it has started at 10 milliseconds. So submission time was 10. So I'll be writing submission time as 10. Okay. Next again, we'll go for P2. So when I come across P2 was started at submission time was 1. So and it was arrival time also was 1. So we'll get the result as 0 here. Again, this will be 9. And coming for P3. So P3 we have, it was submission time was 17 and as arrival time was P3, right? Arrival time was 2, which is nothing but we'll get 15. Okay. So next again P4 submission time was 5 and arrival time was 3, which is nothing but we're going to get the result as 2. So we'll get 26 by 4. So this will be the answer for waiting time. Okay. Next, turnaround time, time of completion minus arrival time. So time of completion of P1 is completed at, so it has completed at 17 milliseconds. So 17 minus 0, which is 17 again. So P2 was completed at 5 milliseconds and it has arrived at 1, so which is nothing but 4. P3 is completed at 26, but it has arrived at 2 milliseconds, which is 24. Again, P4 has completed at 10 milliseconds, but it has arrived at 3 milliseconds, which is 7. Okay, so from that is, if you add, this will be 11, then 35, 45, and 45, which is 52 by 4. This will be the turnaround time. Again, coming for this response time. Response time, we are going to consider only the first time when it has been selected. So P1 we are going to write submission time first time when it has submitted at 0 milliseconds, it was 0, arrival time was 0. Second, P2 was arrived at 1 and submitted also 1, so 1 minus 1. So P3 is submitted was at 17 minus arrival time was 2, which is 15. Again, P4 is first time it was submitted at 5 milliseconds and the arrival time was 3, which is 2. So we'll get the value as 17 by 4. This will be that is say your response time. And throughput is, we have total of 4 process which was executed at 26 milliseconds. So that will be the throughput. Okay. So this is how you are going to consider shortest job first. I'm going to go through once again. First, consider first process P1 is started at 0 milliseconds. During its execution, when it was completed first millisecond, we got one more process. That is, new process has arrived with a lesser burst time. So since it has a lesser burst time, P1 will stop its execution. And instead of executing P1, we are going to execute P2. So P2 will start execution. So that is why P1 will be removed from execution and it will move to the ready queue. So that is why we will consider it as pre-emitting. So removing the current running process from execution is considered as pre-emitted. Okay. Now after this, so during this we will complete P2 completely because it has 4 milliseconds. Even though if you observe at 2 milliseconds and 3 milliseconds we have 9 and 5, which is always, obviously it is greater than 4 milliseconds. So first we are going to complete 4. Next will come for P4. After that we'll go for P1 because it is 7. Then we'll come for P3, which is 9 milliseconds. Based on that, we're going to calculate waiting time, turnaround time, response time as well as throughput. Okay. Similarly, I'm going to explain one more topic called as period scheduling in the continued video. Thank you.